We've been talking about using numbers to describe data sets. So we collect all this data and then we want to summarize it with just some numbers. The first number we talked about quite a bit was the mean. So the mean was just more or less kind of where the middle is. Let's start off drawing a little bell-shaped curve. So here's one example of a distribution, and then the mean just tells you where the center is. So this is a bell or a normal distribution. But there's plenty of other shapes of data that would have that same mean. Let's just take another one. If it's just flat across, still have that same mean. This is a uniform distribution. Or I could say I have a test and I have some students do well and some students that do really bad. I have one bump here and then another bump over here. So this is some sort of bimodal distribution. I mean, this is a very, very different shape, but it still has the same mean as both of those shapes. Or let's do one more. I could have a distribution where actually every data point was equal to the mean. So here's the mean. So a point distribution, or a delta distribution sometimes it's called. So we see this mean, I mean, even though it's very helpful for telling us what our data looks like, it certainly doesn't tell us everything. It tells us where the middle is, but it doesn't tell us kind of how spread out the shape is. If we think about being spread out, this point distribution, it's not spread out at all. The bell distribution, on the other hand, it's spread out a little bit. The uniform is spread out a little bit more, and this bimodal is spread out quite a bit. So we want another number that will be able to tell us just how spread out the distribution is. That number is the standard deviation. So standard deviation. And this video, I'm pretty well just going to give you the formula for it. Next video, we'll kind of talk about why is this formula intuitive. So it's square root of, well, you add up each of your individual entries minus the mean, square them, add those up, and divide by n. This is for population. If it's for a sample, this n changes to n minus 1, but since the computer's pretty much going to be computing for us anyway, I figured I'd just talk about population and then, yeah, just in case you wanted to know, for sample you need to change the n to an n minus 1. If you don't take the square root, that's what's called the variance. If you take a theoretical class in statistics, the variance is actually the more important one. For practical use, though, it winds up standard deviations a little bit more useful. So, if you take some graduate stats course, you'll see this guy a lot. For this class, we'll pretty much just work with the standard deviation. Alright, let's do an example computing one. Let's clear that out. Say I give you the numbers 7, 8, 8, 11, and 16. So the mean is, well, just add them up. 7 plus 8 plus 11 plus 16 divided by how many there are, which is 5. So that's 15, 23, 34, 50. 50 over 5 is equal to 10. So there's our mean. Let me remind you, so standard deviation, we're supposed to take each entry, subtract the mean, and square that. Then we add those up, and then we divide by how many there are. So take the first guy, so 7 minus the mean squared, well, that'd be negative 3 squared, which is 9. Next one is 8, so 8 minus 10 squared is negative 2 squared is 4. Then we have another 8, so 8 minus 10 squared. Again, we get 4. Then we have 11. 11 minus 10 squared is 1. Squared is 1. And last but not least, 16. Minus 10 squared. 16 minus 10 is 6. If I square it, I get 36. So that's all my x minus mu squareds. And we're supposed to add those. So 9 plus 1 is 10. 4 plus 36 is 40. So 10 and 40 makes 50. And I've got another 4, so 54. So my variance is just that 54 over how many points I had, which was 5. My standard deviation, I guess I should figure that out. That's 10.8. My standard deviation is just the square root of that, which is about 3.3. So this number kind of tells you how spread out this distribution is, which you kind of see 7, that's about 1 standard deviation below. The 8 and 11, they're all pretty close to the mean. The 16 is about 2 standard deviations above. So yeah, we'll talk a little bit more about how many standard deviations is a usual value and what's not in the lectures to come. But for now, this number just kind of tells you how spread out is this set of data.